Mark here can control a smart home and an Apple Vision Pro with only his thoughts, thanks to a brain implant from a company called Synchron. As the company gears up for its next round of clinical trials, we spoke to Synchron's founding CEO Tom Oxley to find out how it works, what these milestones mean, what comes next, and how a brain implant designed to turn people's thoughts into action will react to a user's dreams. Let's get into it. Synchron's brain-computer interface, BCI, is designed to allow people living with paralysis to control digital devices using their thoughts.
I can talk to you with my thoughts.
The company recently announced 2 new milestones: the first use of its BCI with Amazon Alexa and the first use of its BCI with the Apple Vision Pro.
The reason we're primarily excited about Alexa is that it solves many of the domains within activities of daily living.
Mark, one of Synchron's trial participants, was able to use Amazon's Fire tablet to turn lights on and off, see who is outside using a Blink security camera, start video streaming, and more using only his brain and Synchron's BCI.
Alexa traditionally has been thought of as a voice-based system, and so this would open up the availability of Alexa control for people who don't have voice control.
Apple Vision Pro, on the other hand, is typically controlled by eye tracking or eye gaze combined with hand gestures. Synchron's BCI presents an alternative to hand gestures for people without the use of their hands. Oxley says this navigation is made possible by Apple's assistive touch accessibility features, and that combining eye gaze or eye tracking with a BCI might have some advantages.
Otherwise, you're using up a lot of the compute power of the BCI to solve the trajectory problem. That's solved really nicely with eye gaze, but the problem is you don't have the ability to make different types of selections, maybe left click, right click, scroll, copy, drag down, menu, back. So if you can send those discrete key press functions on top of the eye gaze, then you've got really beautiful synergistic natural control.
Synchron Stentrode BCI is implanted with a catheter into a blood vessel near the brain's motor cortex. Once in place, users can generate actions on their digital devices using the BCI by thinking about moving their body.
The intent to move your hand versus your finger versus your foot looks different. One of our features is like a dial or a scroll. And that's more about the intensity with which you're trying to move. So the ways in which you control the strength, dexterity, and speed of your body is translating into a digital domain. What we're going to see from now for the next couple of decades is the continuing emergence of different types of control features that come out of the brain. So I think a whole software layer is going to emerge around control features that open up new ways of engaging with systems.
These commands sent from the brain are called digital motor outputs. And Oxley says that as this technology progresses, new digital motor outputs will make these BCI devices more useful, capable, and empowering for users.
The sky's the limit with how good it's going to get, and the more access to more brain, the more the features are going to get, and that's how BCI is going to keep growing.
In another new milestone for the company, Synchron just announced the results of a 1-year study, which paves the way for a larger round of testing.
We had 6 subjects who received Stentrode BCI devices. That takes the total now to 10 subjects. And so we've now collected safety data over 5 years since our first patient received a device back in 2019 to now. We want to know, does it cause any damage to the brain, stroke? Does it cause any blood clots? Does it move? And does it cause any blockage? And we're excited to report that none of those endpoints were met.
Oxley says the next chapter in developing Synchron's BCI will be focused on reliability.
Simplicity really matters. How do you turn the device on and off with your brain? What if you're dreaming? How do you lock it? These simple things that we have solutions for because we use our hands have to be solved for BCI.
Speaking of dreaming, I had to ask if the brain signals from dreams could result in users taking unwanted actions with their BCIs in their sleep.
And there's a lot of electrical activity that is caused by sleep in the brain. We're kind of contemplating sleep activity as noise. We have to make sure that the sleep doesn't trigger a turn on in the system. We've spent a lot of time thinking about it and solving it. We're still not there, but it's an interesting problem.
There's a registry at synchronbci.com where folks interested in perhaps being a part of the next round of trials can sign up. To see a demo of how Synchron's BCI gets implanted into the brain without open brain surgery, check out this video right here. And to see our interview with Mark, the trial participant featured in these demo videos, check out this video right here. As always, thanks so much for watching. I'm your host, Jesse Earl. See you next time with the fam.